What happens to something if you squeeze it really hard? I've spent 7 years thinking about this. I don't mean squeezing with just ordinary pressure, but with a truly cosmic amount of pressure. When a star dies, it gets squeezed under its immense gravity and collapses into a dense blob called a neutron star. Think about 1 million Earths all packed into one ball about the size of Manhattan. That's a neutron star. Each teaspoonful of its matter weighs 1 billion tons. So what could that material possibly be like, and how could we ever find out? This question became a very hot topic the year I started grad school, 2017, because in that same year, scientists made history by detecting gravitational waves that were unleashed by the violent collision of 2 neutron stars millions of light years away, as depicted in this image. That measurement marked the beginning of a new era in astrophysics, in which scientists can collect data that will help unlock the mysteries behind such dense matter. This is a big deal. Even the strange material in distant neutron stars, after all, is made of the same fundamental building blocks, called quarks, that make up you and me and everything you've ever seen on Earth. Early on in grad school, I found all these ideas very exciting, but I didn't really like collecting data. So I was thrilled to discover there was lots of theoretical work to be done in this area, investigating possible types of matter that might exist in neutron stars and making predictions that can be tested with the new data coming in. It turns out that in the bizarre world of quantum physics, there are forms of matter far beyond the usual solid, liquid, and gas. I studied one of these exotic phases of matter using a theoretical physicist's most powerful weapon, math. With over 1,000 pages of handwritten calculations, along with plenty of programming and computer analysis, I determined some key properties of this type of matter. Astronomers have long known that neutron stars are the strongest magnets in the universe, but my work was among the first to really consider the effects of this magnetism on the neutron star's material. I found that such intense magnetism allows this exotic phase of matter to withstand high temperatures without being destroyed. By analogy, this would be like finding out that ice could stay frozen at room temperature if you placed it near a giant magnet. The finding is important because it means this type of matter could, in principle, exist during the intense heat of a neutron star collision. So, what if this new phase of matter does exist? Well, we still don't know what the consequences would be, but understanding these foundational topics will help us build up knowledge in many different fields. And that will just pave the way for more discovery and innovation, which could eventually open our eyes to new technologies that might be unthinkable today. Thank you.